Here you have just basic radical equations. For this type, you want to make sure that your radical is by itself, meaning that you're not adding or subtracting or multiplying it by anything. It's the easiest way to do this. And so I have this 7 that is being multiplied here. I'm going to divide both sides by that 7. And I will get 1 equals the square root of 8 minus m. And now that I have that, I'm going to get rid of my square root by squaring both sides. Whatever your radical is, that index, you're going to take that to the power. 1 squared is just 1. When I square this side, I actually get rid of my square root. So then I can move that 8 over. I get negative 7 equals negative m. Then I divide both sides by negative 1. So m equals 7. And that is my answer here. All right, for this next one, I actually already have the radical by itself, but I do need to square both sides. So I can just start right at that. I don't have to move anything over first. So I'm going to square this side, and I'm going to square that side. With this one, I will get x squared equals 42 plus x. Anytime you have an x squared, you're going to want to go back to your methods for solving a quadratic formula or factoring, okay? In order to do either one of those, it has to be equal to 0. So what I do is I always move everything over to the x squared side. Unless my x squared is negative, then I'll move him over. I always want my x squared to be positive. It's just easier to factor. So I'm going to move the x over and the 42 over. X squared, when I move it over, it's going to change signs, right? So that will be minus x minus 42, and that equals 0. And now I can factor. I want factors of 42 that subtract to give me 1. So I'm going to get x minus 7, x plus 6, and those equal 0. So I'm actually going to get 2 answers at first here. I'm going to get 7 and negative 6. And I need to check for extraneous solutions. So I'm going to plug in my 7 back to my original equation. That is 7 equals the square root of 42 plus 7. 7 equals the square root of 49. That is true. 7 is an answer, all right? Then I'm going to plug in negative 6. Negative 6 equals the square root of 42 minus 6. Negative 6 equals the square root of 36. We are talking about all numbers here. The square root of 36 is 6. There is no variable involved in this, okay? So this is actually an extraneous solution. My only answer here is x equals 7. Once again, I have something that is with my radical that I want to get rid of, that minus x. So I am going to move that x over. On the left-hand side, I have x minus 4. On the right, I have my radical. Now I am ready to square both sides. Here, however, I am squaring a binomial. That does not mean the first one squared and the second one squared. You have to FOIL it, all right? So you have to multiply that out like that. So on the left-hand side, I actually get x squared minus 8x plus 16. And on the right-hand side, I just get rid of my radical. Once again, I have an x squared. Once again, I want to move everything over so I can factor. And so I'm going to move my 6x over and my 24 over to get 0 on this side. And I have x squared minus 14x plus 40. Factors of 40 that add up to 14, well, that is going to be 4 and 10. And so I'm going to say x minus 4, x minus 10 equals 0, which gives me a possibility of 4 and 10. And so just like I did before, I'm going to plug those in. Negative 4 equals the square root of 6 times 4 minus 24 minus 4. 6 times 4 is 24, minus 24 is 0. The square root of 0 is 0. 0 minus 4 is negative 4. So 4 is an answer. And then I'm going to do the same thing with 10. Negative 4 equals the square root of 6 times 10 minus 24 minus x. 6 times 10 is 60. 60 minus 24 is 36. The square root of 36 is 6. 6 minus 10 does equal -4. Those are both answers. Neither one of those are extraneous, so 4 and 10 are both my answers here. Okay, for this one, I actually have a radical on both sides, but then I also have a plus or minus. You won't get the radicals completely by themselves in this situation. And so one of them is just going to have a plus or minus with it. One by itself, one of them with a plus or minus. And so I'm going to go ahead and square both sides because I really can't simplify this anymore before I do that. The left-hand side's the easy part here. Square a radical or square root, you just get what's inside. This one you have to FOIL, okay? So you are multiplying negative square root of 1 minus 5n plus 1 times the square root of -1 minus 5n plus 1. You are squaring it, okay? So you FOIL. When you multiply a root by itself, you just get what's inside. So you're going to get that -1 minus 5n when I multiply this right here. Then I'm going to just multiply that radical times 1. Well, anything times 1 is just itself. So I get that. Then I am going to multiply 1 times the radical. Once again, I just get the radical. And then I am multiplying 1 times 1. That is just 1. All right. So a couple things here. I have a -1 and a +1. Those will just cancel. -1 and +1 will just cancel. I want to move everything over that's not a radical. So I'm going to move this 5n over. Get it out of the way. So over here I have -1 minus 5n. And over here I have 1 times the radical plus 1 times the radical. That gives me 2 times my radical. Okay? So all I've done is simplified this right side. Now I have something that actually looks like my earlier problems. I have 1 plus or minus on the left-hand side. I have a radical on the right-hand side. Now I just need to get rid of my radical again, right? And so how do I get rid of my square root? Well, I square both sides. So I'm going to square this side, and I'm going to square this side. On the left-hand side, you are squaring a binomial, which means you are FOILing. Okay? On the right-hand side, if you squared this whole group, you have to square the 2. 2 squared is just 4. And then when I square the radical, I just get what is inside. So the right-hand side is actually a little easier here at this point. On the left-hand side, I'm going to FOIL. So I have -1 times 1, right? Gives me 1. I have -1 times -5n. I have -5n times -1. And I have -5n times -5n. Okay? On the right-hand side, I'm just distributing. So 4 times -1, 4 times -5n. Okay? Once again, I have a square. When you have a square, you need everything to one side, set equal to 0. I'm also going to rearrange this left side to be an ax squared plus bx plus c form, okay? Meaning I want in standard form. So I'm going to put this 25x in n squared first, right? 25 n squared. And then I have a 10n, and I'm going to add to it this 20n. I'm moving that 20n over. So 10n plus 20n, I'm going to have 30n. And then I have this 1, and I'm adding the 4 over to the other side. So 1 plus 4 is 5. And all of that equals 0. Okay, so I've just simplified it and kind of rearranged it and moved everything to one side. Now here's the thing. You could go ahead and try to factor this the way it is, or hopefully you can see that something goes into all three of those. What goes into all three of those numbers? Yeah, so I could actually divide everything by 5 here. So 25 divided by 5, that gives me 5n squared. 30 divided by 5, 6n. 5 divided by 5, and then that gives me 0. So factors of 5 that add up to 6. I can actually do this because this is a 1, and this will not affect my factoring. Just like if the x squared had been a 1, it won't affect my factoring. So this is going to factor, and you can use the rainbow method where you go across, but this is going to factor to 5n plus 1, n plus 1. Factors of 5 that add up to 6, okay? And now I should know how to solve. Set this equal to 0. Set this equal to 0. So n is going to equal either negative 1/5 or it's going to equal negative 1. And by the way, when I plug those in, they both work. If I plug in a negative 1, I get negative 1 minus a negative 10, so that's plus 10, so I get the square root of 9. And then negative 1 plus 6, or plus 5 is the square root of 4. That's 2 plus 1. So 2 plus 1 equals the square root of 9. That's true. And if I plug in the 1/5, then I am going to get, this turns into a 2, so negative 1 plus 2, that's the square root of 1. This turns into a 1, so the square root of 0. So the square root of 1 equals 0 plus 1. So both of these work. Those are both my answers. Negative 1/5 and negative 1 are both of my answers there. They both work. When you have a fractional exponent, you need to raise both sides to the reciprocal, okay? So I'm going to raise the left side to the reciprocal of that 3/2, which is 2/3. And I'm going to raise this side to 2/3. On the left, it's really easy. I just get rid of my exponent. I just have what's inside. Over here, rewrite it as a radical. It will make more sense, okay? So I want 64. My index is the denominator, cubed root of 64. My exponent is the numerator, squared. Okay? So I'm not going to do anything to the left-hand side right now. On the right-hand side, the cubed root of 64 is just 4. So I have 4 squared. 4 squared, hopefully we all know, is just 16. And then I have a really basic algebra equation to solve. I'm going to add my 5 over. I have negative p equals 21. And I'm going to divide both sides by negative 1. So p here will equal negative 21. And if you plug it back in, you will get the right answer. Negative 5 minus 21, or minus the negative 21, and then 3/2 there. So you will get 16 to the 3/2. 16 to the 3/2 is just 4 cubed, which is just 64, and it works. I pulled one from the bottom of this page as well, number 23. This is just getting rid of radicals that aren't square roots. So the first couple pages are all square roots. This is a 4th root. So for something like this, I would again get the root by itself. So add the 4 over. Negative 1 plus 4 is 3. All right. To get rid of a radical, you raise it to the power of the index. This index is 4, so I raise both sides to the 4. That will get rid of my radical on the right, and then I just do the operation. 3 to the 4th is just 81. So to get rid of a radical, you raise it to the index. The first couple pages were all square roots. but you're not always going to run into a square root. So you want to cube it or take it to the fourth or whatever power the index indicates to do that for.